Okay, so this one is a pretty long one. So consider a plane that is perpendicular to the xy plane and passes through the points P. So we have P, and we'll have that to be, so it has that point, and then we have Q. Okay, so they want us to find the slope. So slope is pretty much a directional derivative uh, uh, of the tangent line to the curve of the intersection of this plane with the surface of f of x at that specific point in the direction of Q. Okay, so what we have to do is, so we need to find a directional derivative. So it's the following formula. Okay, so this is the grad function, and this is, so u is cos theta I plus sine theta j. So let's start by finding the grad function, and we're gonna have, so when we find the grad function, we're gonna have x to be 2 and y to be 1. Okay, I don't know why they gave us 17 there. I think it's just to throw people off, like make them confused. I mean, so so the grad function, it's d of f over d of x plus d of f over d of y. Okay, and obviously f is 4x squared plus y squared. So let's solve this one. So it's 8x plus 2y. Okay, and then we plug in our point, so 2 and 1. So it's 16i plus 2j. Now, we're not given an angle, but we can find our angle using this. So if we take the difference of P and Q, so 3 minus 2, and then 2 minus 1, we get 1 and then 1. Okay? So this will just be 1i plus 1j. That's another way you can write it, because we call this as x and this is y. So we can rewrite it this way. Now, let's take the tan of y over x. So it'll just be 1 over 1. And guess what that should give you? That should give you pi over 4. So that's the degree we're going to be using. So for this, u is equal to cos pi over 4 plus sine pi over 4. Okay? So u will be equal to 1 over square root of 2i plus 1 over square root of 2j. Now we just times this and this with each other. And so it should be 6. So you times the i's with each other and you times the j's with each other. Okay, and now at the end you just add them all up, and that's your directional derivative.